The demands on materials are constantly increasing, so more and more different materials are being used. For example, aluminium, metal, wood, and FRP. The consumption and the application is increasing more and more. Use of fiber-reinforced plastic in our everyday life. For example, Airbus, BMW, wind turbines, and filler cap. What is that? It's a kind of plastic. FRP is constructed as follows. The plastic, which is referred to as a matrix, is combined with the fibers. This results in FRP. The fibers are divided into two categories, chemical and nature. Chemical is, for example, CFK, GFK, and AFK. And nature is, for example, flat fibers and cotton fibers. Why are they used everywhere? Because of their excellent features. A big issue is recycling, since FRP is not biodegradable. There is the possibility to store the components of FRP, for example, rotor blades of windmills on playgrounds. The complete recycling is not possible because there are no recycling methods yet, and therefore the production goes on and the number of trash rises. You can't burn the components because there are no burning stations which are able to do it. The dust that appears after burning FRP is clogging these stations and paralyzes the station. Another problem is that it's hard to grind and crunch the components because leftovers have to be deposited somewhere else. And you can shred the components as short fibers as stronger plastic. So what now? We have to find a biological-based plastic which is recyclable. This would be the optimal way. A good replacement would be shellac. To gather 1 kilogram of shellac, you need around 300,000 paint shell lices. These paint shell lices live on poplar figs and nourish themselves with saps from the poplar fig. They sting the tree and pick up their juice, and afterwards excrete the resinous substance which then surrounds the lice. After some time, they drill through the resin bubble, and that resin bubble deposition is the outcome and main product for the shellac production. When a branch is fully surrounded by resin, it gets cut off, collected, and then the resin gets separated from the branch, and the resin will get grinded, washed, and is then dried in the sun. One way to produce fiber-reinforced shellac is to iron the fibers into the shellac. Shellac is a natural alternative for synthetic resins. It's to highlight that shellac is safe to use in pharmaceuticals and food. It is used, for example, as the glue in cigarettes and cosmetical products, for example, hairspray, and also in the art industry, for example, the ink. Our conclusion is that the studies on shellac have to be continued since there are still decisive negative aspects to shellac. The temperature tolerance is low. At a too high temperature, the shellac melts. We also found out that shellac absorbs water if it gets in contact with it. But overall, shellac has a positive mechanical aspect and is a good alternative to synthetic resins. Ende.
Ja, gut, wir sind fertig.